Hello, my name is Tanja Radusin and I will present the research activities performed within the short-term scientific mission entitled Preparation of Active Packaging Films based on biopolymers and bioactive extracts from plants and fungi by electrospinning technique. The collaboration between Serbia and Spain within the short-term scientific mission was conducted from 15 to 30th of June and lasted in total for 16 days. The home institution, University of Novi Sad Institute of Food Technology, where I am employed on the permanent position as a research associate, present one of the leading research institutes in the field of the food and feed science and technology. The host institution was Institute of Agrochemistry and Food Technology, and this research center is oriented to food science, technology and biotechnology as part of the Higher Council for Scientific Research. My supervisor and host was Professor Jose Maria Lajaron, the head of the Novel Materials and Nanotechnology Lab. The working plan of short-term scientific mission covered few experimental goals, where the first one was the preparation of the polymer extract solution and electrospinning of the prepared system. We have decided to have two different biopolymers just to be sure that we will manage to prepare solutions that are going to be successfully electrospun. The first system was PLA with three different bioactive compounds from plants. The first one was Allium ursinum extract, the second one was Calendula, and the third one was Helichrysum. While for the PHB we have also used the same three extracts. Electrospinning of the prepared system was performed using a Fluidnatec LE10 lab line from Bionesia with a variable high voltages from 0 to 30 kW power supply. The biopolymer solutions were electrospun at room temperature for a given processing time and in optimal conditions to achieve steady fiber formation. The second step was preparation of films from the electrospun mats. So the electrospun mats were subjected to the annealing process using a hydraulic press optimally performed at 145 to 160 degrees Celsius without pressure. The resultant films were air-cooled at room temperature. Prior to annealing treatment, the electrospun films were equilibrated and in dexicators and held there for some period of time. Characterization was conducted on both mats and films to understand the influence of addition of bioactive compounds on polymer matrix properties. The morphology of the fiber was observed on scanning electron microscopy, and spectra of prepared composites were collected on FTIR. Thermal analyses were carried out on DSC and TGA devices, while crystalline properties were measured on wide-angle X-ray diffractometer. Water vapor permeability tests were determined using ASTM 2011, and antimicrobial tests were planned to be done according to the guidelines of the Japanese industrial standard. For the first system, with PLA, only Allium ursinum extract had good dispersibility in prepared solution and easy processing on the electrospinning device, while solution with Calendula and Helichrysum showed significant phase separation, so electrospinning was not possible. For PHB polymer matrix, all three extracts showed very good compatibility and were successfully processed on electrospinning machine. Morphology of the mats of PLA and PLA with 10% of Allium ursinum extract are shown in figures A and B. It's visible that for PLA and PLA loaded with allium morcinum extract, very good fiber formation was achieved. Allium morcinol was probably encapsulated into the fiber, which is visible on the figure B. Morphology of the PHB fiber loaded with different extracts, Helichrysum, Calendula and Allium morcinum, are shown in the figures A, B, C and D. It is visible that addition of different extract has influence on fiber formation and also on the way how the extract will be incorporated into the fibers. On this slide, we can see the FTIR scans of PLA mats with allium morcinum extract. Changes in the spectrum of the PLA loaded with the allium morcinum extract was monitored during time to understand the release of the allium morcinum extract. The first scan shows the pure extract, and the other ones are showing neat PLA and PLA with allium morcinum extract during 4 days. It's visible that there are some changes during time concerning release of allium morcinum extract. On this slide, we can see the FTR scans of PHB mats with allium morcinum extract. Changes in the spectrum of the PHB loaded with the allium morcinum extract was monitored during time to understand the release of the allium morcinum extract from the PHB polymer matrix. From this scan, it's visible that no significant changes are visible on these spectra. Conclusions and final remarks. Electrospinning was an effective technique for producing films of PLA loaded with allium morcinum extract and PHB with allium morcinum, calendula and Helichrysum extract, while for PLA loaded with calendula and Helichrysum extract, this technique was not applicable. Different extracts had different influence on prepared solution for electrospinning, influencing the processing parameters and shape of the fibers. For all samples, transparent films were obtained with visible color change due to the extract addition. All the results concerning characterization and antimicrobial properties will be published in the joint publication. I would like to thank to Professor Lagaron for the opportunity to work in his lab, also his team, Sergio Torres, Adriane, Bea, Eva and Sergio Castro, on their advices and help during my short-term scientific mission. I also have to say that for me it was a great pleasure to work with a team from the Lab 502 because they helped me to feel very comfortable in their lab, and also no matter we were working really hard during these 2.5 weeks, the work was really very fun. Also, I want to thank to the Cost Action Active and Intelligent Fiber-Based Packaging number FB1405 Actinpak for giving me the opportunity and support to have this experience in real work and give both groups the opportunity to widen our research and collaboration between two institutions and countries.